Hello, this video is going to look at a topic from section 5.4 known as a conditional probability. And we're going to look at this with the context of drawing a single card, just one card, from a shuffled deck. So we're dealing with classical probabilities here. Every card is equally likely. For all the probabilities in this video, we're going to be using the idea that the probability of an event is the number of ways that event can happen divided by the number of possible outcomes. And we're allowed to use this because we're saying every card is equally likely to be chosen. So we're going to define 4 events here. And just as a reminder, I'll give you the total number of cards that are of each of these types. And so following the framework that we just talked about, we could say things like this. The probability of R happening is going to be the number of ways R can happen, which is 26, over the number of possible outcomes, which as a reminder is 52. There are 52 total cards in a deck of cards. If you're not familiar with this number, get familiar with it. 52, it's your best friend. So 26 over 52 is the probability of a red card, and we could simplify that to be 1/2. For right now, I'm just going to leave all these in fraction form. We could also say the probability of getting a black card is the same thing. The other half of the deck is black, so the probability of getting a black card is 1/2. And the probability of getting a king is going to be that 4 over 52, and this simplifies down to 1 over 13. And then lastly, the probability of getting a face card is going to be 16 over 52, which simplifies down to 4 over 13. These 4 probabilities are known as unconditional probabilities. We've found probabilities like this before, but we haven't called them this name. So let's look at what conditional probabilities are. First of all, notice the notation here. When we talk about conditional probabilities, we are going to use a straight line. So when we see that, we read, it's the probability of event F given event E. That means it's the probability that F occurs given some information, given that we know E occurs. So when we do conditional probabilities, they're going to look like this format. This is the unknown thing. And then we're going to be given some more information. We're going to be given something we know. So let's look at using these same 4 events. And instead of doing unconditional probabilities, let's do some conditional probabilities. Let's start out by finding the probability that the card is a king given something we know. And so we're going to say we know the card is a face card. So to think about what this conditional probability is, we're going to imagine that we're trying to figure out what's the probability the card is a king. And instead of just us drawing the card, we had a friend involved here. This friend drew the card for us. And they said, without showing us the card, they told us the card is a face card. That's the given information. We know something about this card. We're not just completely in the dark anymore. A conditional probability says you know something about this situation. All those probabilities we've done before were all unconditional, where we knew nothing. But now we know something. We know the card is a face card. So what is that going to do? If we're calculating probabilities, figuring out the number of possible outcomes, well, now we know that card is a face card. Our friend isn't lying or anything like that. The card has to be one of these 16 face cards. So the number of possible outcomes here is reduced. We used to have 52, but that was unconditionally. That was if we knew nothing. And now that we know this given information, then the number of possible outcomes is reduced. Our card has to be one of these 16 face cards. Within those 16 face cards, how many are kings? Well, there's 4 of them. So the conditional probability that the card is a king, given that the card is a face card, is 4 over 16, which is 1/4. Let's find another conditional probability using these same events. Let's find the probability that it's a king still, but now we're going to be given that the card is black. Now that we know the card is black, how many possible outcomes are there? There have to be only 26 possible outcomes now, because this card cannot be anything but a black card. And of those, how many are kings? Well, that has to be 2. There's a king of clubs and a king of spades. So this conditional probability simplifies down to 1 over 13. The probability that the card is a king, given the information that the card is black, is 2 out of 26. So the big deal with conditional probabilities is that the denominators change, because we have some information. Our very helpful friend here told us that the card was black. So now let's look at a conditional probability where we have the same given information. We still know that the card is black, but now we want to know the probability that it's red. Well, I could still think about this in terms of how many possible outcomes are there. There's still 26. But of those black cards, how many are red? Not a lot. In fact, none of them. There is no way you're going to have, if you know the card is black, any possibility of seeing a red card. This conditional probability is 0. If you know the card is black, it's impossible the card is red. What about the conditional probability that the card is black given it's a king? The given information is we now know the card is a king. There's no way this card isn't anything but a king. And so now we're trying to figure out the probability that the card is black. The way I do these is think, okay, I know this card's a king, so how many cards are possible? 4. And now I'm going to count the number of black cards that are kings. Well, there's the king of clubs and the king of spades. There are 2 black cards out of the 4 kings. So this conditional probability is 1/2. So we could also do conditional probabilities using or and too. We could do the probability that the card is red or a king given that we know it's a face card. So now our given information, we know the card is a face card, so nothing else is possible other than a face card. So our total number of possible outcomes are the 16 total face cards. And now of those, we have to think how many are red or kings. Well, there are the 8 red face cards. And then we have to wonder, are there any other cards that are either red or a king? Well, yeah, there's actually the 2 black kings. So again, we're just counting of the face cards, how many are either red or a king. So we have to count the 8 red face cards, but we said or, so we have to count the things that are either red or kings. So the black kings get counted because they are kings, and or means one or the other. So there are 10 face cards that are either red or kings out of 16 total face cards. And I give the answers to all the probabilities in this video as fractions, but recognize that you probably want to go ahead and report these as percentages, just because percentages are easier for people to understand. This video was all about conditional probabilities, which are saying, hey, what's the probability of some event given that I know some information? And the information that I know reduces the total number of possible outcomes. So anytime I see this given line in a probability, I want to think to myself, okay, I am now talking about a reduced number of possible outcomes because I have some information. For this problem, anything that wasn't a face card wasn't possible. So those are conditional probabilities.